This is the Edexcel Higher GCSE paper 3, taken on Monday the 12th of November 2018, so it was a calculator paper. Oops. So question 1, we've got to write down 7357 correct to 3 significant figures. Now remember, 3 significant figures means we're allowed 3 numbers which are not 0. So they're going to be the first 3 numbers. So that's 7 and a 3. Now do we round that 5 up? Yes we do. The next digit is a 7. So it's going to be 736. So they are our 3 digits which are non-zero. But then of course we need to put a 0 in to get everything into the appropriate column. Now with part B, obviously we're going to use our calculator. Make sure you use the fractions button, which is 3 down on the left hand side of most calculators. It's where you've got the little white rectangle over the black rectangle. And then when you're popping into the numerator, you can obviously make sure you're using the square root button. So you get here, if you pop it into your calculator correctly, 0.1077 981 356, and just write down however many numbers come up on your calculator. Question 2. So to work out a percentage increase, it's the increase over the time. So that's going to be 883 take away 245. So the extra amount they're having to pay is 883 minus 245, which is 638. Now to work out the percentage increase, it's this increase divided by the original amount, which is 245. You multiply this by 100 to turn it into a percentage. So 638 divided by 245 equals times 100, and we get a 260% increase. Now it doesn't tell us to what degree of accuracy we want, so I'm going to go 260.4 to 1 decimal place. The answer scheme allowed anything between 260 and 260.5. Question 3, so on the grid we've got to draw this graph. Now because it's an x squared graph, this is going to be one of these smiley face positive parabola graphs. So look out for any symmetry that might already be with your values. So I can straight away see that that -2 lines up with that -2. So just think of it as a pebble just going into the pond here and the ripples coming out. We're going to have symmetry. So that -4 is going to go to -4. I mean, I could check it if I go and put 0 into the function 0 squared plus 0 minus 4 is -4, but it just saves me a bit of time. This also means that as I go and work out the value for 2, it's going to be repeated over at -3, which kind of saves me having to do it for -3. So let's go and work it out when x is 2. So when x is 2, we've got 2 squared, we're adding 2, we're taking away 4, which is 4, 5, 6, 6 take away 4, which is 2. So we're going to have values for 2 here and here. And then when x is 3, so when x is 3, 3 squared is 9, 9 add 3, and then take away 4. So it's 9, 10, 11, 12, 12 take away 4 is 8. So those are the coordinates that I need to plot. So -3 plus 2, so -3 along the corridor. Now it looks like we're going up in little 2's, isn't it? 1, 2, yes, so be careful. So -3, but then plus 2 is 4 baby squares. And then -2 minus 2 is going to be going down 4 baby squares. And -1 minus 4 going down 8 baby squares. 0 minus 4, again going down 8 small squares. 1 minus 2, so down 4 squares. 2, 2, so up 4 squares. and then 3, 8. So after the 5 we need to go another 6 squares above that to there. Just make it a nice gentle curve. Don't give it a flat bottom, make it a nice gentle curve like that. Now for part B we've been asked to use the graph to estimate a solution where the curve equals 0. So this is where it crosses the x-axis, so here and here. Now I think on my graph it's at about minus 2.5, maybe minus 2.6 and 1.6. So as long as your graph ties in with your answers here, that's fine. The mark scheme accepted anything between 1.56 up to minus 2.56. So for 4 part A, work out the percentage of these students who bought 20 or more books. So looking at the graph, we can see 11 students bought between 0 and 4, 8 bought between 5 and 9, 13 bought between 10 and 14, 6, 15 to 19, and then 2 bought 20 to 24. So how many books is that in total? How many students is that in total? So adding up these numbers, 11 add 8, add 13, add 6, add 2, gives us 19, 29, 30, 31, 32, 33, 34, 40. Oh no, we knew there were 40 students, so I didn't need to add those up. So it's 2 out of 40, isn't it? So I've got 2 out of 40. So 2 out of 40, which needs to be turned into a percentage by multiplying by 100. So 2 divided by 40 times 100 gives us 5%. So for part B, now the 11 students who bought between 0 and 4 books, we don't know how many books they actually bought. So we're going to have to estimate that they bought halfway between 0 to 4 books. That's why this part B is an estimate question, okay? So we're going to have to assume that those 11 students bought 2 books, 2 being halfway between 0 and 4. Those 8 students bought 7 books, and so on, 12 books, 17 books, and 22 books. So that is our initial assumption, hence the estimating. So 11 students bought 2 books, 8 students bought 7 books, 13 students bought 12 books, 6 students bought 17 books, and 2 students bought 22 books. So if we add all of those books up together, we get 380 books. So we take those 380 books, divide that across our 40 students, and 380 divided by 40 does indeed give us an estimate of the mean number of books of 9.5 as required by the question. Okay, so Lara completed 475 metre race in 1 minute and 54 seconds. So let's turn 1 minute and 54 seconds into seconds. So as 1 minute is 60 seconds plus the 54, that's 114 seconds. Okay, now we're saying, assuming they go at the same pace, how long would it take Lara to complete a 700 metre race? So 114 seconds for 475 metres. So if we take our 114 and divide by 475, that tells us how many seconds it should take to do 1 metre. Then multiply this by 700, we get 168 seconds. Okay, so just to go over that again, I took my 114, I divided it by 475 to effectively work out how many seconds per metre, and then multiplied it by 700. So that's 168 seconds. So going up in 60s, 2 minutes is going to be 120 seconds. So 2 minutes is 120, leaving me 48 seconds left over. So 2 minutes 48 seconds for part A. Now for part B, we're told that Lara actually speeds up the further she goes. So okay, she's going to be going faster over those meters after 475 meters. So she's going to be completing it quicker, so it's going to take her less time. So how does this affect your answer to part A? Lara will take less time. Lara rather will take less time. So, question 6. We're told that the size of angle B to the size of angle A is in the ratio of 3 to 2. Okay. Now, B and A together must add up to 90 degrees, because obviously C is the right angle, angles in a triangle add up to 180. So we know we're spreading 90 degrees over B and A. Now, B and A together is 5 shares. So how do we get from 5 to 90? How do we apportion it up? Do 90 divided by 5, and we can see we've got to multiply everything by 18. So angle B is 3 lots of 18, which is 54, and angle A is 2 lots of 18, which is 36. So it doesn't really matter which way round we do this. We're just going to have to do SOHCAHTOA to go and work out the angle. So we're being asked to work out the length AB. Let's go and use angle A, shall we? So let's pop the 36 in here. So AC is my adjacent side, AB is my hypotenuse. So adjacent over hypotenuse is cosine. So I can say that cosine 36 equals my adjacent side of 14 over my hypotenuse of AB. So this just requires a little bit of rearranging before I can just pop it into my calculator. So multiply both sides by AB. We get AB times cos 36 equals 14. And then divide both sides by cos 36. So AB is 14 divided by cos 36. So getting your calculator out, just make sure it's on degrees. It should be, unless it should be on degrees. I think mine is. Yes, it is. So 14 divided by cosine 36 equals 17.304. So to 3 significant figures, that's 17.3 centimeters. Question 7, we're being asked to draw a frequency polygon. Now this is always drawn through the midpoint. So the midpoint of 0 and 10 is 5, 10 and 20 is 15, 20 and 30 is 25, and 30 and 40 is 35. So we plot the midpoint and the frequency. So we're plotting 5 and 14, 15 and 18, 25 and 26, and 35 and 12. And then we just go and join these points up with straight lines. Best to use a ruler. Sorry, I don't know, it's not easy for me to do a ruler. So just draw them together, and that's your answer. Question 8. Well, we're going to need to work out what the volume of this cuboid is. So in order to do that, we're going to need to know all the lengths. So let's think about the 3 areas that we were given. This area 45 could be 9 by 5, 9 5s are 45. This 15 could be 3 by 5, and this 27 could be 9 by 3. And that all ties in because we've got the 3, 5 and 9 cropping up all over the place. So it looks like the base of this is 9, the height of this is 5, and the depth of this is 3. And just checking that that works, that means that we've got 9 3s are 27 on top. Yep, that's right. 5 3s are 15 here on the side. That's right. And 5 9s are 45 on the front. That's right. So we know that the width is 9, depth is 3, the height is 5. So the volume of the cuboid of the cuboid is base times height times depth is 9 times 5 times 3, which is 135. Now we're going to melt this down and make it into cubes with sides of length 2.5. So the volume of these small cubes is going to be 2.5 by 2.5 times 2.5. Okay, base times height times depth, all going to be 2.5. So that's 2.5 cubes, which is 15.625. So how many of these little cubes are we going to be able to make when we melt down the cuboid? We're going to do 135 divided by 15.625. So 135 divided by answer is 8.64. Now just be careful here. Work out the greatest number of these cubes that can be made. Well, just be careful you don't go and round this up. Okay, we can only make 8 cubes. So the answer is going to be 8 cubes. So question 9 part A, we've got to expand and simplify. So it doesn't matter which order we do these 3 brackets in, but I'm going to leave the first bracket alone and multiply the second bracket by third bracket. So I'm going to do 2x times the x, 2x times the 1, 3 times the x and 3 times the 1. So 2x times x is 2x squared, 2x times the plus 1 is plus 2x, 3 times the x is plus 3x, and 3 times the 1 is plus 3. So gathering up the second bracket, we have 2x squared, 2x plus 3x is plus 5x, and we've got the plus 3 on the end. So we now do our claw from the first bracket to our new second bracket. So we're going to do x times the 2x squared, x times the 5x, and then x times the 3, minus 2 times that, minus 2 times that, minus 2 times that. So that's going to give us, claw number 1 is going to give us 2x cubed. Claw number 2 will give us plus 5x squared. Claw number 3 will give us plus 3x. And down to the minus 2, that first claw on the bottom will give us minus 4x squared. Then minus 10x. And then minus 6. Now gathering like terms, we've only got the 2x cubed. Gathering up the x squareds, we've got 5x squared minus 4x squared, which is plus 1x squared, which is plus x squared. And then gathering up the x's, 3x minus 10x is minus 7x. And then we've just got the minus 6 on the end. So part B, I think it's easiest here to just start off by multiplying both sides by y squared. So we've got y to the 4 times y to the n equals y to the minus 3 multiplied by y squared. Now when we multiply, we add the powers. Minus 3 add 2 is minus 1. So we've got y to the 4 multiplied by y to the n equaling minus 1. And again, as I just said, when you multiply, we add the powers. So we know that 4 add n has got to equal minus 1 looking at the powers. So therefore n must equal minus 5. So part C. Now to solve this quadratic equation, we're going to have to use the quadratic equation. Well, we don't have to, we could complete the square, but it would be very difficult. So I think using the quadratic equation is much more sensible. So a is the coefficient of x squared, which is 5. So a equals 5. B equals the coefficient of x, which is minus 4. And c is the minus 3. Now the formula which you need to learn is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So substituting in minus b, so that's minus minus 4, which is plus 4, plus or minus the square root. Now b squared, be careful, minus 4 times minus 4 is plus 16. Now then we've got minus 4 times a, which is 5, times c, which is minus 3. We'll do that in the next step. And 2 lots of A, 2 5s are 10. So that's 4 plus or minus the square root of, now minus 4 times 5 is minus 20, minus 20 times minus 3 is plus 60. So 16 plus 60 is 76 all over 10. So our first solution is going to be 4 plus root 76 all over 10. So putting that into a calculator, 40 plus root 76 equals, divided by 10 equals, press the SD button, I get 1.2717. And then my second solution is going to be 4 minus root 76. 4 minus root 76 equals, divided by 10 equals, SD button is minus 0.4717 ... Now we've got to give our solutions correct to 3 significant figures. Now be careful here. The first one is 1.27. Now the second one is minus 0.472. Okay, so 3 significant figures, so 3 digits which are not 0. So it's still 3 significant figures, even though the first one is 2 decimal places and the third one is 3 decimal places. Question 10, so we've got to find f of 23, so we've just got to substitute 23 into the formula. So we've got to find 4 sin 23. Okay, so let's just pop that into your calculators, making sure your calculator's in radian modes. And we get 1.56292. ... So to 3 significant figures, that's 1.56. Now for part B, you've just got to be careful to get this the right way around. We first of all pop 34 into the G function, and that output we put into the F function. So let's first of all put 34 into the G function. So G of 34 equals 2 lots of 34 minus 3. So that's 68 minus 3, which is 65. And then we then take that 65 and put it into the F function. So f of 65 is going to be 4 sin 65. So 4 sin 65, I get 3.625. 23 ... So to 3 significant figures, that's going to be 3.63. Now for part C, we've got to see where Ivan's gone wrong. So let's have a look. X plus 4 all squared equals 25. That's fine. So now when he's square rooted, x plus 4 equaling 5, well that's true, but you've got to remember that when you square root 25, not only do you get 5, you also get minus 5. So it's not fully correct, so it's not wrong, but it's not fully correct because Ivan has failed to pick up the second solution, which is when x plus 4 equals minus 5. So explain why. So Ivan has missed the second solution arising from x plus 4 equaling minus 5. So that would be fine. So we've made it clear that we appreciate that the square root of 25 is minus 5 as well as plus 5. Question 11. Now I think whenever you've got to sketch either the sin, the cos or the tan graphs, just bear in mind that you've something significant happens every 90 degrees, and this is a calculator paper, so you can just go and check any specific values if you wish to. Now tan of 0 is 0, okay, so that will be one value. Tan of 90 is undefined, that is an asymptote, okay, So again, you could just pop in tan of 90 in your calculator and you would see that you get error. So this first part of the tan curve looks like that. Now tan of 180 is going to be 0. Tan of 270 is also going to be undefined. And then you just put your graph in just to hug that asymptote and to hug that asymptote. And then over here, that will be 0, and that's got to hug that asymptote. And what I would suggest you do, if you haven't learned these properly, just double check if you've got time. Just go and do tan of 89 and check you get a really big number. Do tan of 91 and check you get a really small number. Tan of 180 get 0. Tan of 269 big number. Tan of 271 small negative number, a big negative number rather. And tan of 360 you get 0. Question 12. Now, whenever you have one of these three-dimensional trig questions, just try and break it down into two-dimensional sections to really help you gather your thoughts. Now, we're being asked to calculate the angle TAC, and we're told that T is 12 meters vertically above the point at the midpoint of AC. So if we go and draw in the line A to C, and then we drop down a perpendicular bisector so it sits in the middle of AC. Let's go and call that point AE. Okay, and we're being asked to calculate the angle from T to A to C. So if we go and isolate the triangle TA to E, okay, now we're being asked to calculate the size of the angle T to A to C, but that's the same as the angle from T to A to E. So I'm just going to mark that angle there as X, being our ultimate aim to find that angle. Now we're being told that A to B equals 5. So let's just get that onto our diagram. We'll need that in a minute. And we're told that the vertex T is 12 meters vertically above the midpoint. So T to E is 12 meters. So we know that that is 12 meters. Now I'm going to need to be able to work out the length from A to E in order to answer this question. Now if I go and hook out the triangle A to D to C, which is another right angle triangle, A to D to C, A to D to C. Now A to D and D to C are part of the square base, so they are all 5. And E is halfway along A to C. Now this length from A to E is the length that I need. So how am I going to work that out? Well, I can do this by way of a positive Pythagoras. So AC squared, the length of the hypotenuse, equals 5 squared plus 5 squared, 25 plus 25, which is 50. So AC is the square root of 50. So obviously AE, which is halfway along, A to E, is going to be half of root 50. So taking that information across to my left-hand side diagram, I've now worked out that A to E is half root 50. Okay, now to answer the question, let's change colour again. I need to go and work out what what X is. So I want to work out what X is. I know the opposite side, I know the adjacent side. So I know that tan X equals my opposite side of 12 over my adjacent side of half of root 50. So inversing tan both sides, I know that X equals inverse tan 12 over half root 50. Popping that into my calculator, I get 73.583 ... So giving that answer to oh no, it doesn't tell me the degree of accuracy. I'm going to choose to give that answer to one decimal place, so 73.6 degrees is my final answer. Question 13. So all this formula means is the population at the end of the year is 1.101 times the population it was at the beginning of the year. So if we go and just set up a a start and an end of year to give us a chance to think. Now year 1 we're starting off with 400, so at the end of the year we multiply that by 1.01. That's clearly going to be our population at the beginning of year 2, and by the end of year 2 we're going to be multiplying that by 1.01, and that will be what we have at the beginning of year 3, start of year 3. So our answer is going to be 400 times 1.01 times 1.01. So that's 400 multiplied by 1.01 squared. So 400 times 1.01 squared equals 408.04. But clearly we're being asked for the number of animals, so we have to have a whole number of animals. So that's going to be an answer of 408. Question 14. Now we're told that y is inversely proportional to x cubed. So our first line of working should be y equals k over x cubed. Now we're told that y is 44 when x equals a. So 44 equals k over a cubed. So so multiplying both sides by a cubed, we can see that 44a cubed equals k. So rewriting our provisional formula at the top, having worked out that k is 44 over a cubed, we can say that y equals, replacing the k with 44a cubed, all over x cubed. So that is our revised formula. Now we're being asked to show that y equals 5.5 when x equals 2a. So let's go and substitute x being 2a into this formula. So y equals 44a cubed all over x, which is 2a all cubed. So that's 44a cubed all over 8a cubed. Remember, 2a all cubed means 2a times 2a times 2a, which is 8a all cubed. The a cubes cancel out, so we're left with 44 over 8, which is 22 over 4, which is 11 over 2, which is 5.5, which is what we had to show. Question 15. Now this question is dealing with odd numbers, so let's establish what an odd number is. If you take any number and double it, it becomes even. So we can start off by saying let 2n equal any even number. Now when you then go and add 1 to that even number, by definition you have an odd number. So then 2n plus 1 equals any odd number. Now this question is talking about consecutive odd numbers. Now the next odd number after any odd number is 2 further on. So if 2n plus 1 is any odd number, then 2n plus 3 is the next odd number. Now this question is asking us to look at the difference between the squares of any two consecutive odd numbers. So this difference is going to be when we square the second odd number and take that away from the first odd number. That is the difference between the two squares. We're squaring the second number, we're squaring the first odd number, and we're taking away. Now 2n plus 3 all squared obviously means 2n plus 3 times 2n plus 3, and then we're taking away 2n plus 1 multiplied by 2n plus 1. So this first one, 2n times 2n is 4n squared, then plus 6n, which is plus 12n, and then 3 times 3 is the 9. Now I'm going to be very careful with the this second bracket with this negative. So let's leave the negative for now and just multiply out the second pair of brackets. So 2n times 2n is 4n squared, 2n times 1 is 2n, 1 times 2n is 2n, so that's 4n, and the 1 times the 1 is the 1. Now be very careful how you apply this minus. We're minusing 4n squared, minusing 4n, and minusing 1. Minus 4n squared, minusing the 4n, and we're minusing the 1. Now those 4n squareds cancel out, and that leaves us with 12n take away 4n, which is 8n, and 9 take away 1, which is 8. Now we've been asked to show that this is always a multiple of 8. So if we just go and factorise this and take out the 8, we can see that by definition this is always going to be a multiple of 8. So we can just go and say, and therefore always a multiple of 8. Because we've taken the 8 outside. 8 times anything is obviously a multiple of 8. Question 16. So we're being asked to calculate the perimeter of the whole shape. So this is going to equal the length of the arc AB to C plus the length from C to D plus the length from A to D. And we know that A to D equals, they tell us that that equals 14. So we already know that that's 14. So that's what we need to do. What else do we know? We know that angle's 24. And we know that that angle is 140. And we know the radius is 6. So let's start off by trying to work out the length of the arc AB to C. The arc AB to C. Now that comprises 220 degrees worth, so the rest of the circle, that comprises 200, oh no, I want to do that in a different colour, so let's go back. That comprises 220 degrees worth of the circle, doesn't it? AB to C is 220 degrees worth of the whole circumference of the circle. Now the circumference of the circle would be pi times diameter. Okay, so that would be pi times the diameter, which would be 12. But we want to have 220 degrees worth. So it's 220 degrees worth out of 360. So we need to have pi times the diameter times 220 over 360 degrees worth. That's the proportion of the circumference that we require. Now 220 over 360 times 12 times pi is 22 over 3 pi. That's exact, so let's keep it like that. So that's 22 over 3 pi. Now what about working out the length from C to D? Now from C to D, I think it's going to be easier to start off by working out the length from O to D. Okay, so we're using the triangle AOD, this non-right angled triangle, and we have a pair. We know the angle O and the opposite side AD. So we can use the sine rule. So we can go and say that OD over sine 24. Sorry about my dog barking. So OD over sine 24, that's that length over its opposite angle, equals 14 over sine 140. All right, the sine rule, okay? There's an angle and the opposite side. OD is a side with the opposite angle 24. So multiplying both sides by sin 24, we get OD equaling 14 sin 140 multiplied by sin 24. Popping that into our calculator, we get 8.8587 ... So that's the length from O to D. But for the purposes of the perimeter of this shape, we want the length from C to D. Now C to D is O to D, take away the length from O to C, which is 6. So that's 8.8587 take away 6, which is obviously 2.8587. That's the length from C to D. So that's 2.8587. Now adding these three lengths together, we go and get 39.891 ... So to three significant figures, that's 39.9 centimeters. And that's our final answer. Question 17. Now, when we draw a histogram, each of the bars has got to represent the area. Okay, so the frequency represents the area. So let's start off by working out the width of each bar, which is going to be the distance. So 0 to 20 is 20. So this is a width of each bar column. 20 to 50 is 30. 50 to 80 is 30. 80 to 150 is 70, and 150 to 200 is 50. So when we're trying to work out the height of each bar, remember if you're working out the area of a rectangle, it's just width times height equals area. So the height is going to be the area divided by the width. So 120 divided by 20 is 6. 90 divided by 30 is 3. 120 divided by 30 is 4. 140 divided by 70 is 2, and 100 divided by 50 is 2. So those have got to be the heights of each of our bars. So the first bar is going to have a width of 20. So I think looking at the scale, that's going to be two squares, baby squares represent 10. So that's going to be, so the width of 20 is going to be 4 along, but 6 up. Now, how are we going to get a sensible scale to be 6 up? 1, 2, 3, 4, 5, 6. I think that's really the best we can do. So let's go 1, 2, 3, 4, 5, 6. It'd be nice to make slightly better use of the graph paper, but I don't think we can practically. So the first width has got to be 20 wide and 6 high. So using a ruler, please can you go up 4 squares there and along 6. Then our second one's going from 20 to, so that's at 20, that would just be useful for later. Then our second bar's going from 20 to 50 with a height of 3. Then our third bar is going from 50 to 80, so 50, 60, 70, 80. 80 takes us to there. There's 1 square after the middle. So 50 to 80 we need to have a height of 4. And then 80 to 150 we have to have a height of 2. And then 150 to 200 we also have a height of 2. So please can you make sure you do yours with a ruler. So what we're saying, in short, each of these areas then, the areas represent the frequency. So just so you're clear, okay, 20 times 6 would be 120, so that area is 120. 30 times 3 is your 90 frequency. 30 times 4 is your 120. 70 times 2 is your 140. And 50 times 2 is your 100. So that's the answer to the first part of the question. So part B is asking us to estimate the median distance. So how far did the middle student travel? So we've got 570 students. So the middle student, divide that by 2, is our 285th student. So how far along as we go left to right is our 285th student? Well, they're clearly not in the first 120. Then let's take the next bar, which is the 90 bar. So how many students have we now taken account of? That's 210. So our 285th student is somewhere inside that third bar. Okay, they're somewhere in here, aren't they? Our 285th student is somewhere in there. Now, how far student-wise are they into that third bar? Well, we've already accounted for 210 students in bars 1 and 2, so we're 75 students into the third bar. Okay. Now, how many students are in that third bar in total? It's 120. So what proportion of that bar are we going across? It's 75 out of 120, which is 5/8. So we need to go 5/8 into this bar. Now this bar is going from 50 to 80. So we need to go 5/8 of the way along from 50. We need to go 5/8 of the way along. So what is 5/8 What is 5/8 of this extra 30? 50 to 80 is a length of 30. What is 5/8 of that length? So 5/8 times 30 gives us 18.75. So we need to go a further 18.75 along here. That length there is a further 18.75. So that's taking us from the 50. So 50 add 18.75 is taking us to 68.75. So that is the median distance in miles. The mark scheme did allow a little bit of leeway, but that is the precise answer you should be really aiming to get. Question 18. So the question asks us to consider bounds and to give our answer to a suitable degree of accuracy. So we have to start off by working out the upper bound and the lower bound for speed. Now we can see that we're being asked to work this all out in kilometers per minute. So let's just gather our thoughts. So our opening statement is telling us that we're doing 487 kilometers in 3 hours, which is 180 minutes. So we're dealing with kilometers and minutes like the question asks. So next thing, let's work out the upper bound for speed. So the speed upper bound. Now speed is distance over time. Now when you're trying to work out the largest speed, when you're dividing, to get the biggest number you want overall, you want the numerator, the top number, to be as big as possible, so the upper bound for distance, but the denominator to be as small as possible. So just think about it. You're trying to get something as big as possible. You want to be dividing something really big by dividing something by really small. So get it that way round. Now the upper bound for distance, well, the distance is 487 kilometers to the nearest kilometer. So our upper bound is 487.5. And our time is measured correct to the nearest minute. So our lower bound for minutes is 179.5. Now popping that into our calculator, we get 2.715877 ... Okay, now let's repeat for the lower bound. So the lower bound for speed is the other way around. So this is going to be the smallest distance. So the lower bound for distance divided by the upper bound for time. So that's going to be 486.5 divided by 180.5. And putting that into our calculator, we get 2.69529 ... Now we've got to give our answer to a suitable degree of accuracy for the average speed. Now what we want to do, we take into account both these upper bound and lower bound and go to as many decimal places as we can where they still agree. Now to 2 decimal places, okay, can you see that the upper bound to 2 decimal places is 2.72 and the lower bound to 2 decimal places is 2.70. So they don't agree to 2 decimal places, so we can't go that accurate. Now what about 1 decimal place? Well, the upper bound is 2.7 and our lower bound is also 2.7. So that's as accurate as we can get where our upper bound and lower bound agree. So the final answer we need to give is 2.7 kilometers, and maybe just state that as they agree, as the bounds agree to 1 decimal place. I'm not sure you need to say that, but just absolutely copper bottom it as the bounds agree to 1 decimal place. Question 19. So we are going to substitute the linear equation, the bottom one, into the non-linear, the top one. So first of all, make either x or y the subject of the linear one, and clearly it's easier to make x the subject by taking away 2y from both sides. So x equals 1 minus 2y. So we're going to take this and substitute it into the first equation. So 2 lots of x squared is actually 2 lots of 1 minus 2y all squared. Minus y squared. equaling 17. So multiply out that pair of brackets. So obviously that's 1 minus 2y multiplied by 1 minus 2y, and that gives us 1 minus 4y add 4y squared, and we're still minusing the y squared equaling 17. So now multiply all the terms in the bracket by 2. So 2 minus 8y plus 8y squared minus that y squared equals 17. Now gather up all your like terms and set it equal to 0. We have 7y squared minus 8y minusing 15 equaling 0. Now will this factorise? Yes it will, but let's just go and see. So we need the two magic numbers that multiply to be the 7 times the minus 15, which is minus 105, yet add to be the minus 8, and that is 7 and minus 15. It may be that you can factorise this just by inspection, but I need to use this sort of old-fashioned long method. So I'm now going to split my minus 8y into two terms, 7 and minus 15. Doesn't matter which way round, but I'm going to go the plus 7y and the minus 8y and the minus 15y, excuse me, minus 15y minus 15 equals 0. Fully factorise the opening two terms, so we get 7y y plus 1, and then fully factorise terms 3 and 4, minus 15 y plus 1, making sure we get this repeated bracket. So then our final pair of brackets comprises the 7y and the minus 15 and the repeated bracket. As I said, it may be that you can go straight from the quadratic to factorising it, just to factorising into a pair of brackets just by inspection. I'm not very good at that. So how do I make this first bracket 0? That is when y is 15 over 7. How do I make this second bracket 0? That is when y is minus 1. So I now need to go and work out my my two x values. So let's go back to knowing that x equals 1 minus 2y. So when y is 15 over 7, so when y is 15 over 7, x is going to be 1 minus 2 lots of 15 over 7, which is 1 minus 30 over 7, which is minus 23 over 7. Now what about when y is minus 1? Well again, x equals 1 minus 2y, so x equals 1 minus 2 lots of minus 1, which is 1, add 2, which is 3. So our final answer is x equals, when x equals minus 23 over 7, y equals 15 over 7, and when x equals 3, y equals minus 1. That's our final answer. Question 20. So first of all, triangle A is transformed by the rotation of 180 degrees about the point minus 2, 0. So minus 2, 0 is here. So when we go and So when we go and rotate at 180 degrees, and you would have tracing paper to help you do this, you end up with A moving to here. So excuse me doing it by hand. I found it very hard to get the ruler to work on this function. Obviously I would like you to be doing it with a ruler. So that's gone to that. Now this is then followed by the translation with vector minus 3, 2. So every single point is going to move 3 to the left and 2 up. So that shifts the shape to being over here. Now we are being asked that one point in triangle A is invariant under the combined transformation. Now that means that particular point does not move. Now let's think about the points on this triangle. The point that was originally, let's just change colour to help with this explanation. The point that was originally there, okay, the point that was originally at minus 4, 1, it's actually ended up now being over on the other side. It's ended up being there, and vice versa. So The only point that actually therefore isn't changing is the point that's absolutely halfway along, because every other point is just flipping over to the other side. So the point that is invariant is going to be bang in the middle there. So what's the coordinate of that? That is minus 3.5 and then up 1. So minus 3.5, 1.